Alright, today I'm going to do a lesson on complex numbers for my last micro teach. This is what my lesson plan was about. So we're going to kind of go quick through the lesson since obviously we only have 10 minutes. So obviously I do more examples in a real classroom setting, go more in depth. But we're going to try to cover as much stuff as we can in 10 minutes here, get you an idea of what we do. Alright, so first thing, I'm going to pretend I have students, obviously I don't. First thing we're going to do today, class, is we're going to review the real numbers, and then we're going to talk about complex numbers. So looking at this diagram we've used in the past, what are all numbers besides complex numbers encompassed in? The real numbers, right. That's denoted like this. Okay, going in now, what's the next tier after real numbers that everything else is encompassed in? Yep, rationals, good. And I should note, also right here, what goes in here. Not within the rationals, but it's also in the real numbers. Yep, the irrationals, good. Okay, then after rational numbers, what's next? Good, integers. Those are like your negative and positive numbers that you can count, -1, -2, good. All right, then after integers, what's the smallest section of numbers we have? Yep, natural numbers, good. That's denoted by an N. All right, so that's the reals. That's what we spent all of our time doing, pretty much everything. And now we're doing a new set of numbers called the complex numbers. So we got a whole different set of numbers that are complex numbers. A complex number is any number that contains an imaginary root. So what is that? It's denoted by this letter I. And I is equal to the square root of -1. As we all know, you can't take the square root of a negative number, so that's why it's imaginary, it fits into the complex numbers. So we know that I equals the square root of -1. What do we think I squared equals? Yeah, good. It'd be negative, just be -1, because square root of -1 times square root of -1 equals 1, or -1. No, I'm not going to write that. All right, and then I to the third will be this times another square root to the -1. So what's that going to be? Good, negative square root of -1. I to the fourth? Yep, it'll be +1. You can break it down as being I squared times I squared. What's -1 times -1? 1. Yep. So that's, and then this just repeats forever. So I to the fifth will be this, I to the sixth will be this, I to the seventh this, I to the eighth this. Just repeats forever like that. So it's an easy way to remember your different I values. You don't actually have to count out I to the 27th every time. You can look and say, okay, I to the 24th is this, so I to the 27th would be 25, 26, 27. It'd be negative square root of -1. All right, so now the next thing we're going to do is say how complex numbers are written. They're all written in this form right here. A plus BI. So all complex numbers have a real number part and a complex number part. The real number part is the A. The complex number part is this side. A and B are both real numbers, but B, this section, the BI, is a complex number. So an example would be 6 plus 3i. Someone want to tell me what the real part is? Good, 6. What's the complex part? Yep, 3i. So that's how they are written. On a side note, we're not going to do this yet, but you actually graph complex numbers. So if we were to graph a complex number, you have your A, essentially your A and your B. So your A goes out this way at 6. Your B term, 3i, would be up at 3. So it would be out here. That's how you graph complex numbers, but we're not going to get into that yet. Just so you know, it's written that way, and that's how you graph it. We'll get into that later on. All right, so the next thing we're going to do. Okay, so we're going to do some examples now of putting numbers in the correct form. So, one thing you can't have with complex numbers, you can't have an I in the denominator and have it in the correct form if you have a fraction. So let's do a couple practice problems like that. So say we have this example, 3i squared over I. What do you think? So I'll tell you, here's what we'll do. I'll do an example for you, and then I'll have you guys tell me how to do one. So for this one here, you treat just like you're dividing variables. So I squared divided by I to the second, I to the first. You just subtract the powers, you get 3i. All right, I'm gonna let you guys try one now. Let's pretend it's this. Oh, sorry. It's I squared over I. There we go. We're gonna pretend it's this now. What do? Good, you subtract just like it was a variable. So you get, so pretend it's 6i to the second over I to the first. It becomes 6i. Good. Ordinarily, we do more examples, but since we're short on time, we'll move on. All right. So what happens here, though? Now, what if we have more I in the large value of I in the bottom, like this? Then what do? Yeah, you'd have to go down here, subtract down like that, so you end up getting 6 over I squared. And then we remember, what's I squared equal to? Yep, -1. So it becomes 6 over -1 is equal to -6. So that's how you do that. All right, now say we want to write a number in the form a plus bi, but it's not in that form. What would we do? Say it's something like, say we got something like this. Remember, we have to split it up into the reals and the complex parts, so what are we going to do? What do you think we're going to do? Yep, we're going to split up the numerator. Good. So we'll rewrite it like this. Which then equals 2 plus 7i over 3. Good. That's exactly what we do. Let's do another one. All right. What are we going to do? Yep, split it up. So what's going to be in my real term? Yep, 7/3. So that's the real part. Now what's going to be my imaginary part? Yep, 4i squared over 3. Now we have one more thing we have to do before we're done. What is that? That's right. We're going to convert I squared to -1. Which then gives us the final answer of -4/3. Putting it together, it's 7/3 minus 4/3, which is equal to, yep, 1. 3 over 3, which equals 1. All right. Let's move on. All right, next thing we're going to do, we're going to practice adding, subtracting, and multiplying complex numbers. Today, are we out of time? Oh. So today, doing that, we're not going to do division because division's actually a little different than regular division. So we're going to leave that for another day. But addition, subtraction, multiplication, they pretty much follow the regular rules from real numbers. Except you have to split it up. You combine your imaginary parts and you combine your real parts. So let's do an addition example first. 4 plus I plus 6i plus. All right. So what are we going to do? Good. We'll combine everything, the reals and the imaginary. So the reals, 4 plus 7 is, yep, 11. I plus I is, yeah, 2i. Good. All right. Let's do another one. I'm gonna let you guys work this one on your own. And now, okay, so we're out of time. So ordinarily, I'd let them work one on their own, and then I'd have them tell me their answers. We'd go over it together. And if I had real students today, I'd maybe have students come up to the board and work out a couple examples or something like that. But obviously, we didn't even get to subtraction, multiplication of complex numbers. But that's a snippet of my lesson there for you. That's all. Thanks.